A lobster fisherman is keeping track of the productivity of a set of traps he's placed in a favorite location. Below are the numbers of lobsters in these traps over the course of 12 different hauls. According to the 1.5 IQR rule, we're going to find what values in the distribution are outliers. So the first thing that we would want to do here is determine what is our 5-number summary. We're going to need to identify Q1, the first quartile, and Q3, which is the third quartile. Now you could put this data into list 1 in your calculator, do 1-bar stats to get the 5-number summary there, or you can just look at the numbers. Here they are listed out in order. There's just 12 of them, so it's a relatively small data set. So we could start by determining the median. So if we were to count 6 values in from either side, and then we have an even number of values. So the median is technically the average of the 2 middle values. We have 2 5s in the middle, so 5 plus 5 divided by 2 is still 5. The interesting thing, though, about the median here is it's not this 5 exactly, and it's not the other 5. It's technically the average between the two. So we've got the median. We could still determine down here, like this is our minimum value, this is our maximum. And then the other 2 pieces that we need for the 5-number summary are going to be our quartiles. So if we look to find quartile 1 is the median of the lower half. So the lower half is technically these 6 numbers here highlighted in yellow. Well, that's an even number of values. Again, so the median of those is going to be the average of the 2 middle values. Again, the 2 middle values are the same number. They're both 3. So our first quartile is also 3. But think of it as technically being the average between the two, so 3 plus 3 divided by 2. All right, so that's our first quartile. Now let's go ahead and identify the upper quartile. The third quartile is the median of the upper half. So the upper half is going to be these 6 values here in pink. And we have 2 numbers in the middle. Again, it looks like they're both 7. So our third quartile is 7. All right, so let's go ahead and identify the IQR. That's something that we're going to need for this calculation. So this is going to be Q3 minus Q1. 7 minus 3 gives us an IQR of 4. So what the 1.5 IQR rule says is it helps us determine boundaries on both sides. So we're going to get a lower boundary and an upper boundary, whereas if there's a value below the lower boundary, or if we have a data value above the higher boundary, those are going to be considered outliers. So to check to see if there are any low outliers, I always start with this one, is I'm going to see if there's any numbers that are lower than, so it has to be lower than Q1 minus 1.5 times the IQR. So let's just plug the numbers in. So our first quartile is 3, and then we're going to subtract 1.5 times the IQR, and we determined that that was 4. Now this is going to go into the negatives. So it doesn't look like we have any low outliers because all of our values are positive, starting with 0. So our lower bound here is -3. It's not possible to have a negative value in this data set. So no low outliers. The next one, though, that we're going to check is if we have any outliers on the high end. So in order for it to be a high outlier, it has to be higher than Q3 plus 1.5 times the IQR. So Q3 was 7. So we're going to do 7 plus 1.5 times our IQR, which was 4. So when I plug that in, I get that value to be 13. Well, that is how high the value is allowed to be in the data set before we consider it an outlier. And so because that value of 13 would be like right here, we can see that that 14 is outside of that. And so the only value that is technically an outlier, according to this rule, is the value of 14. Thanks for watching.